Today we're going to talk about linked lists, a singly linked list in Rust. We're going to read this post and then write that linked list live on Twitch. And if you're watching this on YouTube, then it's not live. And thus you need to go over to Twitch. I don't have time for that. I don't have time for that right now, Priv. I'm just going to refund you your points. It's hilarious. Right. So right when I start the recording, you want to redeem them on Nightshade, dude? That's funny. Okay. Linked list, Rust DSA. I'm not going to restart the recording at this point. This is the shenanigans we get with Twitch, okay? In the search algorithms post, we worked with sequential data structures, where each element can be accessed by an index. In Rust, examples of this are array, stack, and vec. There's another type of data structure to hold arbitrary elements that is most commonly used in functional programming languages, called a linked list. The main two variants of a linked list are singly and doubly linked. In this post, we'll cover the singly variant and cover doubly next time. A singly linked list consists of nodes linked to each other in one direction. Look at this beautiful pseudocode. Here, our square brackets represent a node, and our skinny arrow represents a link. And so node A links to node B, links to node C. The first node in the list, A, stores a pointer to the next node B, and B stores a pointer to the next node C. Since C is the last element, it has no pointer to the next node. We can represent this in Rust-like code with tuples. This is my change. Okay, we didn't do this on Monday, but I kind of like it. We can represent this in Rust-like code with tuples. Let L equals a tuple of A. The second element is a reference to a tuple of B, and a reference to a tuple of C with none at the end. Obviously, this is not valid Rust, okay? It's Rust-like code, okay? Not public yet. But if you use the blog command, that's the where the blog will be posted. So there's a basic idea of a linked list using tuples. The first node A is called the head, and the rest of the list, BC none, is called the tail. This structure is also closer to what you'll find in languages like OCaml and Lisps. Yeah, mentioned. I wanted to fit this in last time, and I just couldn't figure out how, and then I had this idea. What if we just had a tuple-like linked list, and it kind of shows this head-tail relationship, and I like it. It makes sense to me, but I also am familiar with things like OCaml and Lisp. If we want to add something to our list, it's very easy. All we need to create a new node. I guess it is to do. I think that's more correct. All we need to do is to create a new node and point it to our existing head. Probably better. DABC. This is going to be DABC none at the end of the day. But all we had to do is have our new value D and a pointer to our old list, right? And then this works. Since this is all done with pointers, there's nothing that we have to change in our list nor allocate some except for a new node. This highlights one of the strengths of a linked list, which is that insertions on the front are fast and don't require reallocating existing elements. Deletion is just as simple from the front of the list. We remove node D by simply deallocating that node and anointing A as our head once again, giving us our original list. So obviously, I didn't put in the code here. Again, it's Rust-like, right? We don't have the code to dereference our pointers or anything like that. It's just to give you the idea. This means both insertion and deletion are O1 constant time with the condition that they are operating at the beginning of the list. But unlike the sequential data structures listed above, e.g. vec, we can't access elements by index. Similarly, any operation, whether it's fetch, insert, delete, that's not at the beginning is going to require traversing every element's next node until we get to the desired position. For example, if we want to reach the 100th node, we have to traverse 100 nodes to get there. Generally speaking, these operations are then O in linear time, since the worst case is that you want to operate on the end of the list. It's worthwhile to point out the two primary pieces of advice given in the rust.lib docs about using a linked list from the linked list docs. Note, it is almost always better to use vec or vecdec because array-based containers are generally faster, more memory efficient, and make better use of CPU cache. A great explainer for why this is this video from Bjorn Strustrup, the creator of C++, who can explain it far better than I can. From the stud collections docs, use a linked list when you want a vec or vecdec of unknown size and can't tolerate amortization, you want to efficiently split and append lists, you are absolutely certain you really, truly want a doubly linked list. Let's break down the first two bullet points. The first speaks to the fact that vec and vecdec use a contiguous chunk of memory. If the size of the vec outgrows the original allocation, it has to be reallocated to fit any new elements. In some situations, the cost of resize would be undesirable. Maybe the cost of that resize. Yeah, that's fine. The second points to one of the unique values of linked lists, which is that they are relatively easy and efficient to split. And in the case of doubly linked lists, append. Using our list from before, if we wanted to split the list after A, all we have to do is break the link to B. In actual Rust-like pseudocode, this would have been way too annoying. So to illustrate the point, I made it a little bit simpler, but there's still a lot of text there. I'm not 100% sure that I like this, but it's probably the final iteration. So if we take our original list, I just wrote it out here for clarity, DA, BC, none. If we split after A, in real code we'd use option, take, or similar, because I also omitted the options and the sum types here, the sum type constructor. We have L1 equals DA none, L2 equals BC none. To undo our split, we just have to point A to B again. This is a little bit in the weeds because we're using tuple access syntax in order to make that happen, but anybody that's a little bit familiar with Rust will probably understand how that works. L.1 just takes the second element of that tuple, and .1 again takes the second element of that tuple, because we need to put L2 where none was before. You don't know Rust, whatever I mean. All we're doing is adding or removing pointers for split and append without worrying about changing any memory allocations. Note that appending the lists is inefficient for a singly linked list, but O1 for a doubly linked list, which will be discussed in the next article. Here's a simple implementation of a singly linked list in Rust, having only push front, pop front, split, and append methods. All right, this is the code we're going to write today. So I'll leave the summary up for you to read by yourself later. And let's go ahead and write this code. So first things first, we should be on a nice clean commit, and we should have a clean test. Looks good. Let's go ahead and touch our source linked list .rs, and we'll go in here and that's right, it's a lib. So all we have to do is say mod. Actually, it doesn't matter which order they're in. We'll put it here. It'll be chronologically ordered modules. And here we go. Let's start with this because I always forget to do it. We're going to allow dead code. And then we're going to copy the test boilerplate because it's just what I do. I hate writing it out every time, and I usually forget it. So let's copy the test boilerplate from here. Nice try. Okay. See, I should have just done one more line, and then it would have made sense. Function linked list works. Okay, that looks good. And there's our test. Okay. Yeah, we know. There's nothing there. All right, so like we talked about in the article, what do we actually need here? We're going to need pop front, push front, split, append, and we're also going to do new. So we could actually implement this the same way that I did in Rust pseudocode in the article, in that like you could use a tuple struct and it would work just fine. I'm not going to do that because it's not really as idiomatic Rust as I think using like a named struct. And there would be some annoyances. Basically, I don't want to get into the same thing that the pseudocode did where we're doing this, right? That would be kind of annoying. So we're not going to do that. We're going to create a normal struct. We'll just call it a linked list. We're shadowing the std_lib linked list here. That's fine with me. I don't really care. So this is what we're going to do. And for nicety, we're going to have a len on our linked list, which not all linked lists have to have, but we're going to put one on there. It'll make testing easier too. I don't know. We could try measuring it again at some point in Meet, but not today. Not during my implementation stream. I'm already strapped for time. I mean, I have to write this whole thing today. I mean, do you realize how hard that is? You know how slow I go. All right. So so we can say head. Well, there's two different ways we could write this. We could make this the recursive data structure, or we could have a node struct. That's how I wrote it last time. I did this 6 months ago. I think I want to see what it feels like to just make this a recursive data structure. And so all we're going to have is len. We're going to have value. Oh, this is the part that I didn't like about this whole thing being a recursive data structure, is then we would have to have our value is an option T. Because otherwise, if we initialized it with like, there's no idea of an empty list, it's a little annoying. We could still do that. Our can you text box linked list? Yeah, exactly. I mean, it's not far from what my node usually is actually. And then our tail. So if we go down this path, I don't know, I might change it to the node thing. We'll see what I feel like doing. I mean, the thing that's annoying is that technically this would not be valid. I wish there was like it would be an invalid state for value to be none and for tail to be some. That part kind of sucks. That part kind of sucks about doing it this way. So in some ways it's nicer to just hide the whole node implementation and make it its own struct. But we'll just keep going for now. Our tail is going to be an option. We're going to use box just to make it simpler. I don't have to deal with lifetimes, etc., etc. And this should be a box, not anti, just a box T. Pretty sure that's right. So our linked list then has a len, it has a value, and it has a tail. And that value is optional. Technically, only none if empty list. Yeah, that's where this part kind of sucks. But we can add some handling in our implementation. Okay, so this would be I didn't make this pub, but you know, probably should. I actually can't remember right now if I need to mark all of my methods as public. I can't believe I'm forgetting that right now. Like, because there's public and private methods, right? Yeah, I'm pretty sure everything needs to be public in order for other people to actually use them. So we're gonna go with this. Pretty sure I'm right. Okay, so new isn't going to take any arguments. It's just going to return a self, and it will just be linked list. Think that is how I would write that. Len 0, value none, tail none. Yeah, thanks, Amit. Okay. Now we should start getting some actual errors. Let's see. I guess the problem is that we don't actually like is the thing that kind of sucks about this is it would require them to pass that in. Let's see what the compiler error says here. To specify lifetime type or const arguments. Okay, so I actually have to use the syntax there. That makes sense. T not found in the scope. You might be missing. Right. Yeah, you're right. I just forgot this. Okay. And then it's pretty ugly when you have to do it that way. I wonder, does this work? Do I not have to have that? Ooh, I don't have to have that. Okay, nice. That's prettier. So impl t linked list t, and we're just grabbing, since it knows we're returning self here, and self is linked list of t, then we don't have to add that little guy there. So that makes me happy. Okay, so there's new. Not a whole lot to test yet. Let's just keep going. Let's just say push front. Bro, is there even any music playing right now? There is music. Oh, this is a 12-minute song. That is a very slow burn. Let's go ahead and skip that one. Okay. Okay, so push front takes a mutable self and takes a you sobbing. I skipped your favorite form of music. That's hilarious. Let's just call it a val t. Yep, exactly, pizza. You are correct. Oh, this is where I start hating this implementation as well. Because in Rust, now if I was making an immutable linked list, this would be fine. I'll just write this out and then we'll talk about whether or not I like it or not. How about that? I mean, basically, I would have to say let mute L equals. I guess I can just say self new. And then I would have to say L dot value equals T. Oh my god, I made this a box of T. It's hilarious. I knew that type seemed too simple. I knew that seemed a little too simple. Okay. L dot value equals T. Huh? I said T instead of L. Okay, here we go. Oh yeah, right. I forgot. Which also brings me to the point that this is only... yeah, I kind of think the node is going to end up being simpler. But let's see. Let me just think about this. If self dot value dot is none, we're going to do this. And else self.value is sum. I lied. This is the sum. This is the sum version. Maybe I do want the sum version. Maybe I like that better anyway. Let's change this to sum. Okay. That means that there's actually a value there. I could also just check if self.len equals 0. I guess that's actually a little bit nicer. Yeah, I think that's nicer. Sure. Self.len equals 0. I think that's a little bit more appropriate. Self.len equals 0. Okay. Except this is supposed to be greater than 0. Nice. If self.len is greater than 0, let me L. We create a new linked list. That's the whole point. We assign the value to the new value that we have, and then we assign the tail to self, actually. So let's see if we can do this right. Yeah, I guess this actually has to consume self. That's the thing that's dumb about this implementation. Oh yeah, I know. I mean, it's definitely bookkeeping. Now, what I could do here is add an assert, right? That self.value self.value that is none. I could add that as like an extra check. Can't I add a little message to the end of assert? Yeah, Shakti, see you, dude. I appreciate you dropping in. L doc buffer. Custom messages. Yeah, that's what I thought. Okay, we'll put a real message. there's a value at len 0. That's the problem. So we could do that. Obviously, it's a runtime check, so that part kind of sucks. Oh well. Okay, and then l.tail ends up being some box new self. And then we return L. Rapscallion Reeves, thanks for the follow. I appreciate it. If self.len is not 0, then we end up here. Okay, so before I spend all of my time on this implementation, I already kind of hate it, so I'm probably going to change it after push front. Like this will go away, and we'll just have this next one, most likely. Okay, so this means we already have, like this one, we already have a tree, right? There's already something there. And this one, we don't. Okay. Well, let me think about this. The thing is, even if I had a node, value would become head. I'd still have the issue that if I did something wrong, head could be none. Let me think. Well, head, an optional head makes more sense to me than an optional value. I just think it's a nicer type personally, but it's fine. Let's just finish this. Okay. So if self.len is 0, we have something pretty simple. And this kind of goes back to where it kind of sucks that we moved it in this case. And partly why I don't think this is very idiomatic is because then we end up saying self.value equals some val, and we have to return self. Now, this isn't that big of a deal, but the way we'd have to use this down here is like so. I didn't make self mute. Okay. We would have to say let L equals linked list use size new, something like that. Emacs froze. 1 second. Classic Emacs freezing. And I'm sure it doesn't happen to anybody else, but it does happen to me. Okay. We're down here. Okay. So we have linked list use size new. And then we would expect that doing l.push front 5 would work. But now what we've actually done is we've moved self, and we can't go ahead and use L anymore. So we'd actually have to say let L equals. And actually every single time we use push front, because sometimes it would actually be a new list, we would have to say let L equals. So this works great if you're used to immutable code in functional languages, but most people in Rust aren't going to expect to use it this way. So that comes down to, like, if you want to make a more functional data structure with an immutable linked list, you could do this. But like the normal patterns of using it would have to change, because we can't, like, because in some cases I need the actual thing. I can't do an and mute, right? Like, I don't think I can do a self.toOwned. I don't think this is going to work. Yeah, it's not going to work. We'd have to have clone, basically. And I don't want to have clone. Like, we could do that and just clone it, but I'm not going to. So let's just make nodes. And the nodes don't have to be public. So our struct node T is going to be very simple in that a node always has a value. The value can't be optional. And the next node, or tail, we'll call it a tail in this case. Let me think. Do I want to call it a tail? The only reason I don't want to call it a tail is because you can't use the node tail directly the way that you would a normal list. So I think I am going to call it next for now. And we're going to end up with that option box linked list T. Yeah, next I think is better. Okay. So then our head becomes an option node T. And then this, our tail, let me think. Well, I think we just need len and head, right? Yeah, because we're doing a singly linked list. But I forgot my comma. Okay. So then this just becomes head. And then on our push front, we have new things. So it's up to us if we want to like do a node impl. I probably will. I'll probably just do a node impl. I think it'll make some things nicer. Instead of doing the literal struct syntax. Yeah, let's do it. Let's do it. Function new, and this is going to be value, val t, self, and very simply, we're going to return our node with a value val. Oh yeah. We really should just be doing this. That's a little bit nicer. And next is none. Okay. So that's that. Head none, len 0. This looks fine. We just have to fix this now. Okay. So push front has something similar in that if self.len is not greater than 0, or like we're still going to have this else if else block, but I think it still works. In this case, I kind of like checking if self.head is none. What's the difference? I don't know. I don't know what the difference is. I kind of like doing that here, and we're going to say else here. Now we could add some more conditionals if we wanted to check for invalid states, but we're just going to assume that we did everything right. All right, so self.head is none, then all we're going to do is, and we can take a mutable reference now, we're just going to have self.head equals some node new val. I guess I'll change this to value only because then it's and then we just return self. Now in both cases we're probably going to return self. Let's see. So push front. What does push front actually return in the case of Rust linked list? Let's see what they're. Let's see, because that will tell us also what the idiomatic return value for push front is. That's pop. Push front returns unit. Okay, that's fine. I guess we can return unit. Okay. So if self.head is none, then we give node new value to head, else we create a new node and we say let n equals node new value, and we'll just make this mutable. We could actually, because it's just an internal implementation detail, we could make this a little bit simpler, but we'll start with mutability and see if we want to change it. And what do we call it? n.next equals self.head.take, and then let me think here. n.next equals self.head.take. That gives us that node t. Let me just think. All right. This will actually be nicer in an if-let, but we'll just keep going, and then we'll make it an if-let in a second. So self.head.take is going to give me a sum, but the problem is that sum is just going to be an option node t. Didn't update this. This needs to be an option box node t. We could actually, let's see. So this currently owns it. Do we want to just make this a box and make this code simpler? Yes. I would say that we do. Because if we just make this a box as well, let's just get a right in there. And we return self, but we don't need to because we're actually returning unit. Okay, so now we have n.next self.head.take. That would be correct. And we just have to update our length either way. So let's just do that down here. Self.len plus equals 1. And n.next equals self.head.take. That's correct. Now we just need to set self.head equals sum box new n. Okay. We can delete all that, and this should compile. We'll see if that's true. Okay. That needs to be mute, and now we have push front 5. Cool. It compiles at least. That's nice. Need to do a quick message check, and we'll wrap this up. Okay, so push front is here. That looks pretty good. Let's just see if it's actually working. Let's see if it works. Okay, so here we should have a little assert. So assert eq L, let's say none. L none. This is L dot head is none. I forgot the little guy here. Fearless compiling. Exactly. Okay. And L dot, I already forgot. Oh yeah, that's all. L dot head is none and length is 0, right? L dot len is 0. Node use size doesn't implement debug. What did I do? Is it just because, well, we're going to do debug anyway. It's fine. I guess assert requires debug. It's fine. Let's just say derive. I can't type. Debug. And this is what, use? Or is it import? I forget. Stud format debug. Is it import or use? Oh my god. How dumb is that I can't remember? It's gotta be use. It's use, isn't it? Okay, it's use. Oh gosh. Oh yeah, that's why. It's because I'm doing an assert eq on node. And so you're right. I am gonna need a partial eq. Partial eq. Hilarious, the little things I forget. Okay. Yep. It's because I'm using assert eq. Let's just do a little cargo test. This runs all the tests. I forgot to just run the thing that I actually care about. Okay, linked list works there. That's great. Now we just want to check after we push the 5 is that L.head should be sum 5. Sum 5. Okay. Of course, it's actually technically sum box new 5. This is the only thing that's annoying. Oh yeah, no, actually I want L.head. Let's see. L.head dot. Right. I'd have to do more work than this. Sure. We'll just say let h equals and L.head. And this would be sum box node. Ugh. It's not pretty. It's not pretty. Derive shouldn't require the use import. What are you talking about? Oh, I think you're wrong. I guess you're not. Weird. I got an error on this, but maybe it was just in the Rust playground. I swear it was in the Rust playground. It made me do a... It said it couldn't find debug, and I had to put, like, I had to fully qualify it in Derive. I could be wrong, though. Who knows? It's me we're talking about. All right, how do I actually want to check what this value is? I mean, we know that L.len should be 1. And what we could do at least is just say L.head is sum. And we just leave it as an assert. We could probably just do that. How do I run a single test again? I always forget. Yeah, essentially, like the derived partial eq just allows you to. Oh, like, well, the difference between like actual equality and partial equality is like a whole. That's a whole explanation. That's a whole thing. But essentially, to be able to use equals in Rust, you need to have partial eq implemented as a trait for whatever value you're using. Is it cargo test name? Cargo test. Let's just try linked list. Nice. How about that? How about that? Just like reasonable choices. I'm not used to tools with reasonable choices. Cargo's pretty good at that. Pretty good at having reasonable choices. Okay. Let's just say assert. We're gonna leave it at that, and we'll work on values and stuff when we get to pop. Which we're doing right now. Okay, and this should actually return RT. Okay, so if we are pop fronting, it's an option T. It's an option. If we're pop fronting an option T, no. If we're pop fronting ourself, dude, cargo is pretty darn legit. NGL, right? As the kids say. All right. So then pop front is pretty simple, right? All we're doing is we're going to say if let sum n equals head. Might help if I said self.head. Then this. Otherwise, we return none. Okay. So if there's a sum n, we're actually going to return the n. Let's see how I want to do this. I guess we could do another if let here. We're going to say sum t. Let's call this h, actually. I think that's nice. And then we'll call this n for next and node. Because this is going to be h.next. Okay. Then we're going to do some stuff. We don't need an else on that one. And no matter what, we're going to return a little h.toOwned.value. Except that needs to be a sum. Okay. Yeah, I could do that, Nightshade. You're right. I probably won't though. The main reason I don't when I'm they say no cap now. Hilarious. The reason I don't when I do this is because then I have to construct the linked list all over in my next test. And so I just like testing them all in the same function. And I know there's probably ways to have like a linked list that you're testing throughout different tests. I don't know. But I'm this is Grug. You know how I do. All right. So if let sum n equals h.next, this means that there is a next node on our existing head that actually needs to now be our thing. Oh, we actually don't need that. I just remembered we don't actually need that. So actually what I want to do, this is going to be even better. This is going to be even better. There's a couple things that we can do. First of all, we're going to take this because now we own it. We own that shit. Okay. Okay. We're going to take that. So what that does is it replaces head with none. So now our linked list head is currently none at that line. Then we're going to do a little h.next, and we're going to do the same thing. We're going to do take, and we actually won't need the if let if my brain is correct on this. And instead of doing all that, we can, because I made the type the same, we can just say self.head equals. Oh yeah, this is good. And then we have a little sum h2 owned value, because I'm pretty sure if I don't do the 2 owned, this is going to be not that. Okay, what do you hate about me? Cannot borrow h.next as mutable, as h is not declared as mutable. Right. Easy fix. Okay, pop front looks good. Let's see if it works. Okay, so then we're gonna say l.pop front, right? We don't pass anything there, but we can just do a little assert eq. Assert eq. L.pop front, that should be 5 is the value we put that on there. What's up, Purplish? 22 people here and Purplish gets second. What is going on? What is going on with you people? I'm just kidding. There's a couple links, by the way, if you're not a regular around here. Good point. Good point, Nightshade. Rapscallion says define a creator function in the test module. Yeah. I think that is usually how people do it, because you can just have a normal function in here, right? So we could have like function create ll blah blah blah. Yeah, we could do that. I just have one because I'm lazy. Okay, so to assert eq l.pop front 5. What did we forget on our pop? I saw it before I wrote the test. Is I forgot to do a little len minus equals 1. Does Rust have len? Do they have plus plus in Rust? I don't think they do, right? Like as an assignment. I don't think they have that. You just have to do minus equals. Okay. This means there actually was a thing. Equals minus. Oh my God. It is equals. No, minus equals. No, this is right. Oh no, you're just answering my question. Okay. We're good. So the reason this test is wrong is just because I forgot the sum. What are you growling about? What was that about? Oh dear. He's earthing, as we call it, because it's not a real bark. Let's go. All right. And to be sure that we don't screw this up, we should check that our l.len is 0 again. And we should check that our head is none. L.head none. All right. Beautiful. So let's just do one more where we push some more things. Let's push a 5. Let's just push a few things like a 4 and a 3. I don't know where I'm coming up with these numbers. Okay. And then we should see this all work. Pop fronts. Sum 3. I won't do like a crazy amount here, but we're just going to make sure that we didn't make any really dumb mistakes. This should just be assert, not assert eq. Okay, L.head is sum and assert eq. L.head is sum. Yeah, we're getting there. We're getting there. I'm almost thinking. Okay, I just want to make sure that our length, you know, I mean, I know it works fine. Of course it's fine, but we just want to make sure that we didn't do anything too stupid here. And this is supposed to be eq. It's funny that people like gawk at linked list in Rust, and literally this is easier than a binary search if you were here last week. All right. For me, at least. For me. Let's just do it. Assert that L.head is none. It's kind of funny that I did an assert eq L.head none. I don't know. It's not that different, I guess. And this is L.len 0. Yeah, the DLL is definitely harder. No doubt. No doubt. Looks good. So there you go. If you didn't want anything else, at all, 59 lines. And that includes all these, which we don't even really need. Let's get rid of that. Like, you could whiteboard this. It's not that hard. That's our like extremely simple linked list. I do want to do split and append because I think it illustrates some aspects of this that I think are interesting. So split. What do I want split to do? I think I'd like split to actually consume and then return a tuple of self. The problem is we have to say where we want to split, right? How do I want to describe where we want to split? I guess we're just going to use an index, even though we don't really have one of that. We don't have one, but we'll just pretend we do for a second. We could call that steps. Like, how many steps do you want to split at? I don't know. Anybody, what do they call it in, I bet OCaml. Let's look at the OCaml list module real quick. OCaml list module. Because I don't think the linked list has a split. It has a split off. Split the list into two at the given index. Okay. Okay, we'll just borrow Rust's. We'll say at. So they do a thing which makes sense, kind of, where they just take an and mute self. The benefit, of course, is that then if you're calling split like inside of another function and you don't have the actual thing, then that works better. But I kind of like this. I don't know. I'm trying to decide. The problem with me is that I tend to make things not idiomatic. So maybe we'll make them idiomatic today, this time. Okay. Split off. Yeah, split at does make sense. It is kind of funny that it's split off and then it's at, but I guess it's because split off does insinuate that we're not consuming the other list and that you still have it, right? So we'll say split off. I'm happy with that. I'm going to do one more up here. Everybody loves these tests, right? You guys think these tests are great. I hope so. Okay. Because we're going to put our split here. We're going to put our split tests here. We're just going to have one giant ugly test function. Okay. Here we go. Split off for mute self at usize. So the Rust version panics if at is greater than len. I think what actually is nicer is I'm just going to return an empty list, or I could make it optional. This is actually where I'm going to make it not. I'm not going to do the thing they said. I think we make this a little bit. I think we just make this optional. I kind of like that better than panicking. Switch how you do testing, please. Do you mean like literally switch testing, or is the joke, are you just making a joke that you want me to switch how I do testing? What's wrong with this, Nightshade? What's wrong with this? That's the joke. Okay. Well, might have to refund your points later if you remind me. It's ugly as sin. Yeah, it's fine. All right. Public function split off at usize. Okay. So let's see. There's a couple ways we could do this. How do I want to do it? How do I want to do this? I guess we're just going to do a... Yeah, okay. Let n equals self dot head. While we're going to write a while loop, guys. You know how much I hate writing loops, but I'm going to write one. Let's see if I can remember how to. This is what people keep telling me I shouldn't be doing, is writing recursive functions in Rust all the time. So I'm going to try not to, okay? I'm going to try really, really freaking hard. Doesn't this work? While let sum n does this work? Am I completely off? I don't write these things, like I said. I think it is while let. All right, I'm going to try it instead of look it up. All right, while let sum n equals... Oh, no, that's not how that works. That's if I want to do... I think I need to still do while. I do want that, but... Oh, I'm having a hard time. All right, I just have to look it up. I'm too annoyed to not look it up right now. Rust by example is my favorite thing to look at, so I can just recode. While. No search results for a while. Ouch. Really? You don't have a while? There it is. I thought there was a while let. Am I like crazy about that? I guess I thought that was true. Like while let iter.next type of thing. Oh, it's right there. While let. Okay, let's see if we can do this with while let or not. While let sum I equals optional. Okay, cool. And then I can just update the definition of optional, because this just gets executed on each iteration. Okay, that's what I want. While let. So I have let in, and I have to make that mute, of course. Okay, let mute in. While let, we'll just say node. Yeah. Sum in. Let's call it next. I like that better. Sum in equals next. Perfect. We've got our box node T. That's what I wanted to write. If I just wrote it, I wouldn't have even had to look it up. Self-soothing through the Rust docs. That's true. Once I see it written out, I'm just like, okay, my anxiety can calm down. All right. While let sum in equals next. That's the other thing, is we want to be yeah. I'm getting there. I think what I want is let I equals 0. Ooh, this is going to be kind of ugly. I'm kind of mad that I decided to do this right now. While let sum in equals next. I'm kind of thinking maybe I want my while loop to actually be while I while at is greater than or equal to I, and then I just do an if let in there. If let sum in equals next, and then we go on, and if there is no next, we'll see how ugly this is. Otherwise we return none down here. We'll just go with this for a second. Let's comment that shit out. We'll go down this path for a minute. If let sum in equals next, else none. Does this make sense? No, I actually hate this. I like it the other way. Because I'd rather just do an if check if we're actually there yet. So all we have to do is track our index manually. And so we have to say I plus equals. So we're going to say if I equals at. Then we do our actual work. There's our base case. We're going to just do an early return. Return some. For now, I'm just going to return self because it's going to be nice for the type. If I equals at. Okay. So this will already handle if I'm at the end of my list. The while handles if we've consumed the whole list. This checks us for our indexes that are at, and then we're going to return something that's not self, but you don't need to know that. All right. Otherwise, we do I plus equals 1, and we say next equals in.next. Okay. How about this for some procedural code? I don't think I've ever written such procedural code on this stream. How about it? Okay. If I equals at. All right. So now we're going to actually do our split. And our split is going to be, we know we have our next. What we don't know is, let me think, does that part matter? That part does not matter. We're getting there. Just give me a second. We're going to say let L2 just because it makes sense to me. We're going to say that is in.next.take. That already split our list. This is our new head. And so all we have to do now is say, so actually this should be let H. Hey, Infinite, what's up? We're going to say let L equals linked list. I could have said self new, but it's fine. We'll say linked list new. Say mute. And we're going to say L.head equals H. We can probably make that shorter in a second. And oh yeah, we don't even have to do all of that. Oh, I almost did manual bookkeeping and when I didn't have to. L not push front H. That would have been funny. Oh wait, no. I see why I'm doing it manually. Just kidding. I really do have to do this manually. I could create like a little method for it, but it's fine. We're just going to say L.head equals H and L.len plus equals 1. Okay. Oh, actually, we don't know that. Fuck. All right. Hold on a second. This is the other piece. Okay. So we also have to update self.len. This is where this gets annoying. So self.len equals what? It equals I plus 1. Before we update self.len, we just have to do... We could do this a couple different ways, but L.len is actually going to be equals self.len minus I minus 1. Is that right? 4, you split at 1, and you have 3. Yeah. I'd say that's right. Maybe it's wrong, actually. Hold on a second. Actually, I think it's just self.len minus I. Yeah, I think that's right. I think it's just self.len minus I. Because if you split at 0, that means you have the same length. And if you split at 1, that means you have 1 less. Because it's inclusive of the indexes going into the next one. Yeah, so it's self.len minus I. Okay. I think this is good. You're trying out Jekyll, but it's kind of hard to use. Hey, Alice, what's up? We got our very simple linked list written very fast, which isn't going to be surprising to you, but it is surprising to a lot of people. So here we are. Shook to your core. I know, Badger. I know. But I've never written the split off an append in Rust before, so it's a little bit of thinking. This part takes thinking. The other part doesn't take very much thinking. There's just a lot of bookkeeping. All right, so we create our new list. This becomes this. We can make this simpler by just saying in.next.take. Oh, this is where I actually have it wrong. Hold on a second. Let's see what Rust does. What I mean by that is returns everything after the giving index, including the index. That's not okay. Turns out including the index. D dot split off 2 becomes just sum 1. Split dot pop front sum 1. Okay. So, okay. So we are currently doing the same thing, but I didn't do this right. I didn't do this right because the way I have it written right now would actually, it would actually be exclusive of the index. We'll just say split off after, and then my code is right. Okay, we're not going to do that. Let's just leave it wrong for a second and just... Okay. Looks like it compiles. Almost. It almost compiles. This should be some L. Okay. If it's wrong anyway, why am I going to go through and fix all of this? That's the real question. Because how much am I going to actually have to change here? Okay, let's just leave this down here for a second. And let's think about this code. If instead we did if I plus 1 equals AT, okay, actually, then that would make most of this code correct. If I plus 1 equals AT. I'm going to do this just to be like 100% sure this doesn't bite me in the ass later. Yeah, let's just edit this code. Just kidding. Okay. If I plus 1 equals AT. Our new head would be n.next.take. And it's fine if that's none. But we kind of want to know if it's none. That's the only problem with this code is now it's going to get kind of ugly because I'm going to have another level of nesting. I'd really rather not. I could map the next take. Like oh my God, Michael. I could do this. And this is next. Really what this is H. This is our head. And then I could put all that linked list code in there. Ooh, it hurts my functional heart to put a bunch of stuff in this closure. Is that even going to work? I don't think that is going to work. It's not really what I want. No, it's not really what I want anyway. Okay. That's a bad idea. Okay. So let's start with this. Let h equals in.next.take. Okay, so why are you mad about this? Are you mad because I've already moved things? Is that why you're mad? Oh, it's because I don't have a mute on in, first of all. This has to be mute. Nightshade's permabanned on this channel? Yeah, of course. Who do you take me for? Of course I permabanned him. All right, let's just see what the actual build error is. Let mute next equals self.head. Right. I get that we've kind of like taken ownership here. And I want that. But is that what this is? No, this is just, where is it warning me about my move? Oh, no. Cannot move out of self.head, which is behind a mutable reference. Oh, I'm just being dumb. Okay, we're good. We're good. We're good. I think this could work. Let's see what this ends up doing to us. Next equals in.next. That's not the same. Okay. Let's see what our next problem is. Expected option box node T. Yeah. This is where an iterator wouldn't, well, it actually wouldn't work very well with an iterator. But now this is not working because this next and that next is not the same. Like, how does that work? Borrowed value does not live long enough. Of course it doesn't. Okay. So that is what it is. That's that. Split off. If I just did this the original way and not the Rust way, it would have been nicer. Yeah, I'm glad you could confirm that, Nightshade. Thank you. If I just returned a tuple of two lists as a split, I think I would have already been done. It's annoying. All right, I got to do a quick message check. We'll try to finish this up. Okay. So self is behind a mutable reference, so we can't just take head. We can't do it. Okay? But if we make this a borrow, then this is a borrow. And if this is a borrow, then it doesn't live long enough, which means we have to either provide a lifetime reference, lifetime parameter to split off, or I have to do this a different way that's not annoying. I think I can do this. I actually don't remember. Does this work? Does that work? Might not. Is that not valid rest? Might not be. It still doesn't matter. Even with the lifetime, it still doesn't matter. Okay, interesting. Let's try something else. I did not expect this to not work. Oh, I'm really... Okay, we're just going to go back to my original implementation and say fuck. We're going to do split so that I can at least finish this. I'm going to admit defeat for the time being. And we're going to return a tuple of self. And I think I'm actually sure we'll still do an option self. Yeah, no, it's fair. For some reason, I'm just having a hard time knowing exactly the right way forward with that. Okay, so all of this is correct. Except for where I actually mutate. No, I can still mutate it. That's fine. We're just going to do self sum L. I do need to make self mutable. Like I just typed self because I said self. That needs to be mutable. This is self here. This is self here. And return explicits have to have this. We're still having the issue where technically I've already moved it up here. So that doesn't actually get rid of the problem. Okay, well, I guess we have to fix this problem no matter what, don't we? What if we took a mutable reference here? Would that be okay? You give me a different problem? Does that work? Wow, that is a lot. That is a lot of red. It just turned everything red. Okay, because that's not valid. That's why it turned everything red. Because now it can't even parse the syntax. What do you mean I can't do this? Yeah, there's a lot of skill issues right now. I'm still like, you know, just to remind everybody, we got the original linked list done very easily. These are special extra methods that we're implementing right now. Oh, fuck. Okay. So split, consuming self. I move self here, and because I've moved self here, it won't let me return self down here. Oh, I know how I can fix this. I know how I can fix this. By not doing this. And instead, we say split split equals L. Granted, I could just call this split right here. Do I want to do that? Might as well. There's really no difference. So actually, we're going to turn it back to L, since all that's already L. We're going to do that. Oh, that's why we're not going to do that. Just kidding. Split. Nope. And split equals sum L. Okay. And then I just need to go back here and say let mute L. Taking L's everywhere, exactly. Okay, so this is getting better, but it's still not completely there. And I'm still getting this move problem. So I don't know if it actually solved anything. I don't know if not doing the early return actually solved anything. Because I still basically have the exact same fucking error. Value used after partial move here. Let H, wait, where was this? In.next.take. I never used this? Oh, right, because I changed it. I don't need that line. It's actually correct. Value used here after partial move. Partial move occurs because self.head has type option box node T, which does not implement the copy trait. More information about this error. Okay, so what's the right way to do this then? I can't just go through. All right, so I just have to think about this. I have to think about this from the beginning. How do we can figure this out. I can do a clone. It's not the only solution, Priv. It's absolutely not the only solution. I can do a clone, but we just have to talk about what we're actually trying to do and how we can satisfy the borrow checker. Now, I'm not saying we're not going to do clone. I don't want to be too harsh there. But we shouldn't have to do clone. Okay. So the point is we need to know what the head is, right? We need to be able to ideally mutate. Oh, that's not a bad idea. I could, at the end of the day, I could go ahead and allocate everything to a new list. It's a bad choice. Actually, it is a bad idea. Just kidding. So we need ownership of head, and we need ownership of self. But do we actually need ownership of head, or do we just need this to be a mute? I think it's really that we just need this to be mutable. We don't actually need to own it. I think that part's true. Feral Xenomorph, thanks for the follow. I appreciate it. We're going to work this out. Can't you just take the tail at that position? Can't I just take the tail there? Let me think about it. Like if I just take the tail up here, you mean? And then I do the while let on the tail. I'm thinking about this. The reason I didn't want to take is because if like take actually modifies, right? Up here. And so if we're not at the right index, if I'm calling take right away, then I have this ownership and then I have to like reassign it sort of deal. But maybe I misunderstand what you mean. So like iterate through until you want to split, take the tail to split the ownership, and then return both. And mute self head. Is there a difference? Like, do I still have to call this mute? I still have to call this mute if I want to actually reassign it, right? That's just saying give me a mutable reference. All right. There's got to be a way to do this with a mutable reference. The problem is here we have n. All right. I'm going to comment this out real quick. And see what other problems they give me. Move occurs because n has type box node t, which does not implement copy. Sure. Oh. Is that not right? Expected box node t found and mute. Okay. Okay. And mute option box node t. This expression has type and mute option box node t. Expected box node t found and mute. And mute next. I don't think I can put an and mute there. See what happens. Yeah, then we're just at and mute and mute. It's already and mute. What, you mean up here? The let and mute? I don't think that's valid. Is that valid? Let some in. Okay. Let me just go back to this real quick. Oh, yeah, you might be right. The linked list is already written. Linked list is really easy. The split is hard right now for me, but the linked list is already done. It's less than 50 lines of code. Linked list is a piece of cake. It's not even complicated code. This is literally all the code is. Couple structs. We don't even need the news if we, news are just nice syntax sugar. The split is where I'm having an issue. Yeah, the inline type hints are really helpful. Let me just think about this. And mute option box node t. Okay, now I finally have an and mute box node t, which I think is what I want. But the problem is if I want to reassign next on each iteration, this is no longer this. I think I am going to have to do a box. I think you're right, Nightshade. I think the problem is I would need a box on this box. because I'm going to have to move this shit. Okay. What if we did do this? In.next, I could try in.next.asmute. Yeah, that's what I was thinking. Okay, let's just see. Can we do an asmute? I think we're going to still have the same issue. Expected mutable reference and mute option box found enum option. Oh, that's right. It just makes the inner value on an option and mute. Okay. And if I do it the other way, ugh. So this doesn't work because it doesn't live long enough. Wait, why does this work? Am I crazy? Was that the thing that was, it was literally just saying that it didn't work before. I didn't even change anything. This literally wasn't working before. What did I mean, I changed the and mute here. I added a couple things, but I literally tried this at the beginning. Oh my God. You know what it could have been? I might have not even pressed save at one point. Maybe I just didn't press save at one point. Or Rust Analyzer finally gave up on me. Oh my God, I spent 20 minutes. And it was literally right before. Yeah, there were a couple little changes. We made some changes. Oh God, Rust. Rust is lovely and I hate it all at the same time. Okay. I love Rust and I hate Rust. Okay. We're good. We're so fucking good at this. It makes sense that we need mutable references all the way down here, right? We don't want to move anything. We need these mutable references everywhere. And that's what I thought would work once I got the move error, but somehow I messed up. Ooh, what a June announcement. Is it a new language, Prophet? Search for easier, safe systems programming. Okay, cool. I'll leave that up. We're going to read about that when I'm not on a time crunch. Okay. Here's split. I think split might actually work. And we can actually go back to the original. Okay, let's just test it before we do this. Let's test it to make sure that it in fact does work real quick. Let L equal, no, not quite. Let L split equals L dot split. We want to split at 2. Okay. Actually, I think I want to split at 1. I want to split at 1 so that I can easily keep the rest of my tests. But we need this to be mute. And we will need this to be mute. An easier Rust with a simpler alternative to lifetimes. That's cool. And then here, we don't want this pop front. We just want assert eq. First of all, let's do assert eq. If I knew how to type, I'd be so much better. What is it? Split dot len 1 assert eq split dot pop front sum 2. Okay. Oh, right. It's an option. I forgot. We'll just do this. Split is sum. Wrap. Unwrap. It's because I moved it, right? Fine. Grug style. Alice, is your point that you think I need an easier language? Is that your point? Cannot borrow split as mutable as it is not declared as mutable. Yeah, my fault. I actually don't even need... There we go. Yes. Nightshade, shut up. I didn't ask you. All right. Y'all done?
Yeah. Do you want me to stay until 3:30 and you tell me sometime, or just now?
You can just head out if that's cool with you. All right. Cool. See you, Emma. So we don't need this mute, but we do get a panic on this unwrap. That doesn't sound good, does it? Why do we get a panic? Assertion, left equals right fail. Oh, it's just because of a failing test. That's good. Split.len. Oh. I'm being dumb. I actually want this to be split, and I want this to be L. I know that doesn't make as much sense, but that's what we're doing. And then that way all of that is still correct. Wait, no, I don't. Oh, this is annoying. Okay. That it is what I want, but I'm still annoyed by it. Okay. Let mute L equals... Yeah, I'm really fucking this up now. We're getting wild. Yeah. Absolutely. This is beautiful. This is very beautiful code. Yeah. You guys love it. I know. Oh, it won't be that bad. I'm not going to do as much on it. Most likely. Let's see. Left equals right, failed. Left 3, right 2. Okay. Where? 105? 105? Why do you think this is right? L dot pop front. Sum 3 is correct. And why? Oh, that means my len's wrong. That means my len is wrong. My len calculation is wrong. Okay. So let's see. If we split it 1, if we split it 0, inclusive, we'd be at self.len minus 1, minus I, right? Because we have the whole list. If we split at 1, Why would it not be self.len minus I? I'm a little confused. We're not going to have time to do append, sadly. Why is this wrong? Split L dot split 1. Okay. Okay. Split dot pop front sum 2. That part's correct. We're good. We're good at that. And self.len I plus 1. So this is correct. This is correct. This is correct. This is correct. This is wrong. So len is 2 here after we've popped off 3. How the F is that true? I guess we can do a debug print. L, let's just do a debug print of L. Really? Do I have to put it before linked list, I'm guessing? Really? I don't get it. I thought that was like a thing. Cannot be formatted using, oh, I thought I derived debug on this. Did I just derive it on node and not, oh, that's dumb. That's dumb. I do have to do the dash dash? Okay, thanks. For some reason, I didn't think I had to do that for no capture. Yeah. Okay, let's see. Up here, we printed it off after we split. Our len is 4. Our list is right, but our len is wrong. What did we do? What did we do, guys? Self.len is I plus 1. That's correct. Self.len minus I. How did this happen? L.len is 4 here. That's correct. We split at 1. Are you subtracting the length of the segment you're splitting off? I am. I guess that's more straightforward. I didn't actually think about that, Prophet. Shh. I might have forgot about that. No, I was thinking I could set the len to just I plus 1. Why did I think that would work? Wait, why do I think self.len equals I plus 1 is even right? Oh, no, that is right. That's right for the thing that we split off. So it's not that one. I already got confused. Okay, it's this one. So I did subtract this. Now it would be a little bit more like now at this point they would both be wrong, but it would probably be a little bit more expressive to say like self.len minus equals L.len. Self in this case isn't the part I'm splitting off. It's actually the part that is staying in the array, technically, or the array, the list. Okay. Now this is going to end up being wrong. Yeah. We'll get there. It's fine. It's fine. Thanks. All right. It's right because it's just like our index, like the index we're at +1 is our length, right? Because wait. Why is that right? It's not right. So why is I 0? Oh, yeah, it was right because we're doing I +1. That's why. Goodness. Okay. I think I'm just getting myself too confused though. And that's why this is wrong, is because we're saying minus I, but I is 0 because we changed it to I +1. So it was right. It was right in my original calculation, but it's not right anymore. So either I can say self.len minus I +1, and then this would be, oh wait, but it's actually wrong. I'm sorry, -1, not plus. I was thinking I +1 and then subtracting that, but if we just do minus, then that's actually correct. I'm just trying to think if there's something nicer than that. Minus I -1. I don't think there actually is. I think it's fine. I think this will work. Yay, it worked. Okay. They're split. How about it? Let's see if I have time to do append. 1 second. We can try to do append real quick. I might not finish it, but I'd like to finish it for their article, so I'll probably end up finishing it off stream anyway. And we'll just return units. And basically we need to get all the way to the end. All right, so this is actually going to look somewhat similar now that we have that. Hopefully it won't be quite as painful. I mean, basically I'm looking for a none though at the end of the day. Let me think about this. I'm looking for a none. Is this how I want to do it? Probably. I think that's fine. Yeah, I think it's fine. While let some, we'll just start with this, and I might have to change it. Next, and we'll just get this. And mute in.next. I mean, saying next here is kind of like a little annoying. Maybe I do want to say node instead of next. I think I like that better. Node. Because what I actually want to do is here check to see if next is there. Now, of course, the problem is, the problem is if head is none, that's the only thing that's a little annoying about this, which kind of makes you think you want to do like a for loop or something instead. And just do an if let. Might be nicer. Thinking through it. Yeah, the whole point is I basically just need to get to the last node, right? So if this is none, while let sum n equals node. I'm working on it. I really just want to assign it to the very last node, which is the very last point that there's none. Okay. Oh yeah, this would actually work. Let me just see. Maybe I don't have to do anything special here. Let's just think. Let's think through this code real quick. Okay. So if node is none, the while let loop is actually not even going to do anything, right? Why is this being weird? Okay. If node is none, then the while let loop isn't even going to run at the very beginning. Like if head is none, right? And then this will load, keep going until n.next is none. And that's actually what we want. But let me think about this. In what case is this not going to work? I think this will work, but I don't know for sure. I think that I can then say next dot replace L dot head dot take. Am I right? I don't know. Except it's not next, it's node. Let's see if I'm right. I might not be right. Okay. Yeah. That's fine. Hold on a second. What are you actually saying to me? Expected box node T found option box node T. Oh, right. Isn't there L.head.take? Is that not how that works? I really thought it was. I thought it was just node.replace for options. Let's look at the option docs real quick. Why is replace not what I think it is? Replace. It takes the T. Okay. Replaces the actual value in the option by the value given in parameter, returning the old value if present, leaving a sum in its place without deinitializing either one. Right. So we just have to do it a little different in that the option here has to be... Okay, that's easy. So all we have to do is say if let sum h equals L.head, then this. Otherwise, we don't actually have to do any changes anyway. Okay. And this becomes, it should be l.head.take, by the way. This becomes h. And maybe we don't need l.head.take since we own that L. Let me think about it. And it's just going to drop it after this. It just depends on how like explicit we want to be. We could do that or we could not. I don't think it matters all that much. I guess it hates me for doing that. Oh, I didn't declare L as mutable. It's fine. Let's just try L.head. I think that'll work. It builds, therefore it works. You know what I mean? Okay. Okay, so let's just do something easy and say let mute L. I guess we can just use the same L. It doesn't really matter. We can say L.push front. L's currently empty. We'll push front 5. We'll push front 6. We still have the split that we can use. So we'll just push front 8. And then, you know what I forgot to do? I forgot to update the length. Classic me. Let's see. If let sum h equals l.head, node.replace h. And if there's not an h, like there's nothing to actually add. So I guess we'll just put it in this if let instead of outside of it. We can say self.len plus equals l.len. Okay. Let's see. The split ended up being really, really ugly. And I'm sad about that. But, you know, I think this will be okay. Let's just say split dot append L. And then all we want to do is check that our length is correct, for one thing. I think this is a lot of fun, dude. I mean, it's fine. I mean, you do you. I'm having fun. Like, I mean, I get frustrated sometimes. Don't get me wrong. I think it's great. It's not L, it's split, isn't it? Split.len should be 3. I don't want AI to take my job. I like my job. Generally. Boom. First try. Append is very easy compared to split. I mean, I guess split probably wasn't that hard. It was just the effing borrow checker errors. Now I'm kind of lying though in my article, aren't I? Split is so ugly. And it makes me sad to say, here's a simple implementation of a single linked list. And then I end up having this split method right here. It's pretty gross. Is it any better if I go back to the like studlib implementation of making it an and mute? Like it is a little bit better. Then I have to update all my tests. I might do that later. I'm not going to do it on stream. Hey, you know what? I don't remember when I started this video, but the point is we did a linked list in Rust today. The basic linked list was a piece of cake. The split and borrow checker kind of fucked me up. It's not Rust if that doesn't happen to you. And well, I know how long I've been streaming Nightshade. I don't remember when I hit record. And Append took us just a couple minutes. It's really not that hard to do a linked list in Rust. A singly linked list, that is. Next time we are going to do a doubly linked list. That is next time in this series. And that is a little bit harder. Not going to lie. We'll see how far we get on stream. It's going to be some, we'll probably, I don't know if we're going to do split and append. I mean, split and append really isn't that much harder on a doubly linked list. It's actually easier to do append. It's actually a lot easier to do append. So we'll probably just do split and append. We'll probably do push front, push back, pop back, split, append, new, and call it a day. It is a little like we didn't do any nice test utilities in this. So that made the testing ugly, and me being lazy made the testing ugly. Let's be real. But all in all, I'm happy with this linked list. I think it turned out pretty well. It's fairly idiomatic even, which is not always the case for my Rust code. So I'm pretty happy with this. I like that Prophet never actually answered. She never actually answered whether she was suggesting that language because she's saying Rust is too hard for me. She never actually answered that question. So I think we all know what that means. All right. No, I know you did. I'm just messing with you. Kind of. It depends. There's different parts of me that have different opinions on whether I'm taking that seriously or not. All right, let's push this up. If you want to see this code and you're on Twitch, there'll be a link in the YouTube. If you want to see this code, it's here. I haven't made a command for it yet, but there's that. All right, see you, YouTube.